What does an ancient Indian blacksmith making bullock carts have in common with a rubber balloon? Sounds surprising, right? Long ago, skilled blacksmiths called Lohars had to fit strong iron rims tightly onto wooden wheels. To do that, they heated the iron until it expanded, placed it onto the wheel, and as it cooled, it shrank to form a tight fit. Now imagine this, a balloon placed on top of a bottle, and suddenly it starts to expand all by itself. No blowing. How can that even happen? What's inside the bottle that could push the balloon outward? And what happens when that air is heated and then cooled? Think about it. We'll come back to this mystery. Let's zoom in, way in. Imagine a crowded dance floor. When the music is slow, everyone stays close and moves gently. That's what particles do when they are cold. They move together and stay closer together. But when the music speeds up, everyone moves faster and more energetically, spreading out. When particles gain heat energy, they move faster, collide more, and push away from each other, taking up more space. This behavior is called thermal expansion. Thermal means heat, expansion means increase in size. When materials gain heat energy, their particles move more and spread out, causing the material to expand. This happens in solids, liquids, and gases, but it's strongest in gases and smallest in solids. When materials lose heat, particles slow down and come closer, causing contraction. And this idea isn't just in labs, it's used in real machines. Take the Lockheed SR-71 Blackbird, one of the fastest jets ever built. At extremely high speeds, air friction heats the aircraft to very high temperatures. Engineers designed it so that its part expand and fit correctly during flight, working perfectly under those extreme conditions. But who first demonstrated this idea clearly? Meet Willems Gravesande, a scientist from the Netherlands. In 1722, he showed that a heated metal ball expands so much that it cannot pass through a ring it previously fit through. That's the same principle engineers rely on every day. When designing bridges and railway tracks, they leave small gaps or expansion joints. As the material heats up and expands, these gaps prevent bending, cracking, or buckling. When it cools, the material contracts back safely. And this is how structures stay safe through changing temperatures. So, if you enjoy solving problems like this, you could even become a civil infrastructure engineer and design systems that work reliably in real world. So next time you see something expand with heat, maybe even that balloon, ask why. I'm Dr. Kavita from Urjeevi SPARK. Join us to see more such wonders in action.